Alright, it's time to answer one of the great philosophical questions of our time. How do rockets work? If you ever find yourself gazing up at a rocket taking off, and you're like, hey, how do that thing go? Zoom! Then this video is for you because today we've explain how these beautiful machines defy gravity and take us to space. We're gonna start with the basics of what a rocket actually is. At its most basic, a rocket is just a vehicle that can carry stuff into space. And the stuff it carries is called its payload. The payload could be a satellite for communications or reconnaissance or whatever else we want to put up there. It could be an astronaut in a space capsule headed to the International Space Station for some quality time with their friends Joe and Samantha, or it could just be a bunch of metal. In 1968, Apollo 15 carried the first lunar rover to the moon. So they had to get all that rover stuff up there too. And you know what? All that extra weight actually helps the rocket out. We'll explain why later on. The key thing about a rocket is that it does need a launch site like an airplane does. Rockets can take off from just about anywhere. They just need a clear line of sight to wherever they're going and enough space to accelerate. While airplanes need a runway, rockets need a launch pad. Okay, fine. That was a lie. But not every rocket needs one. Some smaller ones can be launched by hand or even by a regular old cannon. But for the big boys, a launch pad is essential. Launch pads are special structures built specifically to support the weight of the rocket and provide fuel, electricity, and other necessities so the rocket can power up and prepare for takeoff. Alright, now that we have all that out of the way, let's answer the question of the title. How do rockets work? Well, first, they burn stuff. Everything in the universe has gravity pulling it down. That's why when you jump, you come back down. Earth's gravity is a force, which we'll call F equals M times 9.8. That means the force of gravity depends on the mass of the object. Multiplying a number by itself over and over again is called exponentiation. And in the case of something like a rocket that starts with a large mass but loses it as it burns fuel, things can get complicated. Now, we do have to worry about that right now, because we just talking about getting a rocket off the ground. So let's pretend that the rocket doesn't lose any mass as it goes up. That means the force of gravity acting on the rocket gets smaller the farther away from Earth it gets because there's less atmosphere for the rocket to push against. But rockets don't just fight gravity going up. They also have to fight gravity coming down as the rocket accelerates upward. It pushes against the air molecules below it. Those air molecules collide with ones below them, which collide with ones below them, and so on until the force of the rocket is spread out across the entire atmosphere. To lift off, the rocket needs to generate a force equal to or greater than the force of gravity. Once it does that, it'll keep accelerating upward indefinitely, like forever. In fact, that's why rockets never run out of energy. They just keep burning fuel and accelerating until they reach the speed of light, almost. Okay, maybe they do run out of energy, but you get the idea. Okay, so we know that rockets burn stuff, and that allows them to push against the atmosphere and go up. But where does that energy go once it leaves the rocket? Momentum is conserved in a closed system, which means that if a rocket gains momentum going up, the atmosphere must lose momentum going down. The atmosphere molecules gain kinetic energy as they collide with each other, and that causes them to move faster and the temperature around the rocket to increase. It's basically the opposite of what happens when your car's engine cools down. That's why rocket engines look blue. Blue is just hot air molecules being all like, woohoo! I got a lot of kinetic energy. Now we know that the rocket pushes against the atmosphere and that's what gives it momentum. But what makes the rocket go zoom in the first place? It's the combustion reaction inside the rocket engine. Combustion is what happens when you mix two substances together and then set them on fire. Like when you burn wood, you're really setting it on fire. In rocket engines, the two substances that get burned are fuel and an oxidizer. For most rockets, the fuel is some form of hydrocarbon like propane or hydrogen, and the oxidizer is liquid oxygen. A combustion reaction occurs when the fuel and oxidizer mix and burn, releasing energy in the form of heat and light. That heat and light make the gases inside the rocket engine expand, which generates a huge amount of pressure behind the engine. That pressure pushes against the nozzle of the engine, which is pointed in the direction that the rocket wants to go. So the rocket takes off straight up or sometimes a little bit sideways, depending on how it's oriented. As the rocket ascends, the fuel and oxidizer continue to burn, which means that the gas inside the engine continues to expand and push against the nozzle. Eventually, though, the rocket will run out of fuel, and then it won't be able to generate thrust anymore. But by that point, it'll be going so fast that it won't need any more thrust to keep going. In fact, that's how most rockets end up in space. They get to a certain altitude and speed, and then they cut off their engines and coast the rest of the way. That SY. Sometimes ULLC a rocket with its engine still on, and sometimes ULLC it with its engine turned off. It all depends on how much fuel it has left and how fast it needs to go. So that's how a rocket works. But how do those big rockets that carry astronauts and satellites to space work? The answer is pretty much the same way, except they're a lot bigger and more complicated. Let's take a look at NASA's Space Launch System, or SLS for short. The SLS is the rocket that will take astronauts to the moon on NASA's Artemis missions. It consists of three main parts: the core stage, the hydrogen fuel tanks, and the Orion spacecraft. The core stage is what gets the rocket off the ground and into orbit. It contains the fuel and oxidizer for the engines, as well as the engines themselves. The hydrogen fuel tanks are attached to the core stage, and they contain the liquid hydrogen fuel that powers the upper stage of the rocket. The Orion spacecraft is what actually carries the astronauts to space. It's attached to the top of the rocket, and it has a crew module, a service module, and a launch abort system. The crew module is what the astronauts will ride in. The service module provides power and life support for the crew, and the launch abort system will take the crew to safety in case something goes wrong during launch. The core stage of the rocket is powered by 5 engines that burn liquid oxygen and liquid hydrogen fuel. The engines are arranged in a circle around the rocket's center of mass, which helps to balance the rocket as it ascends. The hot gases produced by the engines are directed out of the rocket through the nozzle, which produces thrust. As the rocket ascends, the core stage will eventually run out of fuel, and at that point, it will separate from the rocket and fall back down to Earth, where it will be destroyed in the atmosphere. The upper stage of the rocket will then ignite and propel the rocket and its payload into orbit. Once the rocket reaches orbit, the payload will separate and continue on its way to space. If you ever get a chance to watch a rocket launch in person, definitely do it. There is nothing quite like seeing a giant rocket take off from the ground and head straight for the sky. All right. Now it's time for you to answer the question. How do rockets work? Comment your answer below. And hey, thanks for watching this whole video. It means a lot to us.